So when we are representing the software system and its data element in the terms of simplified diagram, then what are the advantages we can get? Mainly it is of lower cost. When we are representing this entity and how one entity is related to another entity with the help of diagram, then we can see that as a ERD or entity relationship diagram. What are the additional features apart from the standard feature? Everything will going to be stored and described in this control specification. Hello everybody, a warm welcome to one and all. Welcome back to the last session of your Unit 2, and we are in the B.C.A 6th semester subject called Software Engineering. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session, we'll just have a quick recap of my previous session. So as we all know that in the previous session of this chapter, we had a discussion regarding user interface requirements. So there we got to know that we have CUI and we have a GUI, that is graphical user interface, and also we have a command user interface or command line user interface. And also I have discussed regarding what are the characteristics we have with respect to the user interface requirement, along with that UI prototyping. And also I have discussed regarding what do you mean by software document, what is the necessity of having the software document, and what are the types of software document we have. Along with that, we got to know regarding the software system analyst along with its roles and responsibility. So in our today's session, we're going to see how this analysis modeling in software engineering is working out. Along with that, we'll see what are its objectives, then elements of the analysis model, and also we'll see the components or elements of this analysis models. Under that, we have a data dictionary. At last, we'll see about the data, functional and behavioral models. So about all these models you are going to learn in depth in the coming units. So as of now, you are just going to understand what is data modeling, what is functional modeling, along with the behavioral modeling. We'll see about the first topic, that is regarding analysis modeling in software engineering. So now we got to know that we have collected the requirement and also we have done the feasibility study, whether it is possible to implement or not. If everything got over, then the analysis needs to take place, right? So the analysis of all the requirement which is collected by the customer or the end user will going to be analyzed by the analyst. So after that, that needs to be converted into some structured form. So for that reason, we are going to have this analysis modeling. So it's a technical representation of the system. Already I told you, right, regarding the collection of requirement, how we are going to collect the requirement from the different stakeholders or from the different end users. So after that, when we are doing this analysis modeling, at that time it will going to represent the technical terms of the system, how it needs to be developed, like what are the number of modules it must include. All the things which is related to the technical aspects of a system will going to be represented in the analysis model. So it will going to act as a link between which one? So here system description and design model. So this system description is regarding SRS, that is software or a system requirement specification. It will going to have a complete description of that. So once we got analyzed all the requirements or SRS document, that needs to be converted into design model, so that in between it will going to create a link, that is considered as what? Analysis modeling. And also here it will going to include information, behavior and function of the system will going to be defined, and also it needs to be translated into the architecture. As I told earlier, once the analysis is done, so that needs to be converted into representation form. So that's why we are calling that as a architecture here. So that, and also it will represent the component and interface level design in the design modeling. So in order to do all those things or represent all the requirements or components of a system in the terms of architecture or a design perspective, we are going to have this analysis modeling. And also you can see some of the objectives of analysis modeling, why it is necessary, for what reason we have to do this analysis modeling, why the technical representation of a system is important. So that mainly it will going to establish a way of creation of a software design. As I told, like first we are going to collect the requirement, that needs to be analyzed. Once it got analyzed, then that needs to be design. So if we have a design format of a requirement, then we can easily do the implementation, or coding part can be easily done once we have a well structured designing part. So that for that reason, in order to analyze all those requirements and converting that into design part, there we are going to require this analysis modeling, and also it will describes the requirements of the customer, right? So when we are analyzing, we will get to know what are the requirements of a customer, and also it will define the set of requirements which can be validated once the software is built. So in the analysis, and it's a role of analyst also to validate the requirement of a customer has been satisfied or not. So that is also one of the objective of having this analysis modeling. Then what are the elements we have with respect to this analysis modeling that you can see in this diagram briefly, right? It will going to completely consist of data object description, how data will going to be communicated with other object, and how one object will going to establish a relationship between another object. All those will be there as a one more element here. And also here we have a control specification, how control will going to be established between the objects or between the transaction, what is happening. And also we have a state transition diagram here. So you are going to learn about all these diagram in my coming slides. So here entity relationship diagram, in short it will be considered as what? ER diagram. And also we have a data flow diagram, in short it is DFD. And also we have a process specification, importantly we have a data dictionary. So these are the elements, or these are the components which we have in the analysis modeling. We'll see about the each type of modeling now. So first we have a data modeling. So if you see your syllabus, you can see that we have a data modeling, functional modeling, and also we have a behavioral modeling. Then what about this data modeling? As we all know that data can be anything, right? It can be text, numbers, alphabets, or a combination of all those image. So which needs to be processed will be considered as what? Data. When we are representing it in the terms of designing or architecture, then we can say that as a data modeling. So that it's a process of creating a simplified diagram of a software system and the data elements. So here what we are doing, we are representing the software, or we are representing the software system and its data element in the terms of simplified diagram. So just as we like 1000 words is equal to one image, right? So if we have one image, that may equal to 1000 ones. Instead of saying or explaining the scenario, if we got to know or if we see the image or a pic, then it will be easy for us to understand the situation. In the same way, here the complete software system along with its elements of that system or data elements of that software system will going to be represented in the terms of simplified diagram. So in that diagram, that will going to include text will be there, and also it will going to include some of the symbols in order to represent the data and how it will going to be flow from one module to another module or one object to another object. So when we are representing that, or that process of representing that system software and its data element in the simplified diagram, will the help of the text and symbols will be considered as what? Data modeling. And also mainly it will provide a blueprint for designing a new database or re-engineering the legacy application. So whether it can be new application or a old one. So with the help of this data modeling, that will going to be represented, and also this will be helpful in order for analyzing the data objects and their relationship with other object will be considered as what? Data modeling. So with the help of this data modeling, we will able to analyze analyzing the data objects and their relationship with other objects. So when I say system or a software, at the time it will not going to consist only one object. So there may be 100 number of objects you can have. Then how one object is interacting with other object, and how one object is communicating, and what is the relationship between one object with another object, everything will going to be represented and analyzed with the help of this data modeling. And also you can see that some of the benefits of having this data modeling. So when we are representing the software system and its data element in the terms of simplified diagram, then what are the advantages we can get? Mainly it is of lower cost. So no need to have any of the software or any other utilities are not so required. So it will be of lower cost. And if we have this data analysis modeling, then there will be a better management of data as a resource. So if you consider the IT sector, or if you consider any corporate sector, there they are going to treat the data as a resource itself. Like it will be more confidential, it will just going to fetch the money, so that the better management of data we need to we are able to manage the data as a resource when we are having this data modeling, and also designing repositories and databases. So with the help of this we can create or to design repositories along with a database, which is logical connection of or logical related collection of set of data elements will be considered as what? Database here. And also we have a accurate representation of objects. So that will going to specify its behavior, along with that it specifies the characteristics or function what it will going to perform with a particular object, and how one object is related to another object. That's relationship will going to be specified in the data modeling, and also mainly it will going to have a better performance. Then what are the diagrammatic representation which comes under this data modeling? So there we have a relational databases, in short that is RDBMS. So when we are representing the data in the terms of table which consists of rows and columns, there it will going to include the text and certain symbols we are going to use, right? So that is also one of the type we have in the data models. In short it is entity models. And also we have a object database. So no SQL here, so that it will going to be used, or data model concept will be used in order to represent these kind of diagrams. And also we have a graph database. So it is of tree. It will going to have a top-down approach. So in order to represent all these, we can have the data models, and all these representation of a data which comes under the data models. So next what we have? Function model. So now we got to know that in the data that shows how one object is going to have a relationship with another object. As the name indicates here in the function model, what it represents then? This will going to give the process perspective of the object oriented analysis model, and also this will give the overview of the what the system is supposed to do. Mainly this function modeling is going to concentrate on the functionality of a system, what it's supposed to do and how it will going to be done. All those will going to be represented in the function model. Mainly represent what? Perspective of the object oriented analysis model and its overview of a system, what it has to do. So that is regarding function modeling. And also mainly it will going to define about the function of the internal process in the system, external process, and also we have an internal process. Internal process will going to be defined with the help of this function model. And also it is a structured representation of the function, and what that function consists of. It will going to include certain activities. For example, when you have one model, what is its functionality, how it will going to be transferred from one state to another state, and what are the action it is performing, and what are the processes it is carrying. Everything will going to be represented with the help of this function model, so that if I say it as a function, then it may comprises of activities, action, and also processes along with the operations within the model system or a subject. That is what function model. Mainly it represents the functionality, that to internal functionality of a system. So what behavioral model specifies? We can see here, behavioral model bases the gathered requirements on the user interaction with the system. So here mainly it will going to focuses on getting the data and details from the user by interacting with them. Instead of that, we are not using any of the formulas, or we are not having any of the rules and regulation and process flow. So instead of that, they are bothering about the expectation of the customer or stakeholders from the particular system or a software which is going to be built. So that is what behavioral model, based on the expectation of a customer. They are not bothering about how it will going to be function and what are the formulas and rules and operations that we are using. Instead of that, they will only focuses on the requirement of a customer. They will get to know what are the requirement of a customer, like how the system needs to be worked for them. All those things will going to be taken as a behavioral model. So here you can easily understand that mainly it will going to focus on the requirements from the operations of the software can perform to the behaviors of the user, expectation and exhibits when operating the system. So instead of bothering about the requirements from the operation, like how we are going to perform the operation and how it will going to satisfy the requirement of customer, instead of that their focus is on the user expectation, what they are expecting from the system. In order to reach their expectation, how we are supposed to build a software or a system, that will going to be analyzed and modeled in the behavioral models. So now we got to know regarding the types of modeling. So now we'll see about the structured analysis. So you are going to learn about the structured analysis in depth in the unit 3. So as of now, here structured analysis, as we all know that analysis is all about analyzing the requirements of a customer, right? So after that, that needs to be converted into some designing format in order to understand or to which will going to be helpful for the implementation of a requirements which is given by the customer. So that in the structured analysis, it will going to work with, or it started as an information flow modeling technique. So here we are going to use this structured analysis as an information flow modeling technique. How information is flowing from one system to another system or from one module to another module. All those will going to be analyzed in a structured manner. So for that reason, we are going to have certain what symbols or to represent this structured analysis in the terms of diagram. So here we are going to use the rectangle. So rectangle, it will going to specify what? It will specify the external unit. So that can be system element like hardware, software or a person, and then another system that will going to provide the information for transformation by the software or receives the information provided by the software. So mainly when we are representing any of the external unit in the terms of rectangle symbol, that represents a person or any of their hardware or a software and how it is used in the software. And also we have a circle here. So that circle will going to be help us in order to represent a process or which going to transform or the function that is applied to a data and changes it when some way. So when we are using the circle in order to represent certain operation that specifies the process or transformation or a function that which is taking place or which is applying to the data and how it will going to be changed when we are applying certain data. So in order to show the transition, here we have a circle and we have an arrow here that represents the one or more data items. So how data is moving from one module to another module, what is the relationship? So for that we are going to have this arrow mainly in order to represent the flow, like how information is flowing from one module to another module. That is what structured analysis. So you are going to learn about this structured analysis in my coming session in depth. So as of now, we'll see about the entity relationship diagram. In short, it is ERD. Entity relationship. Can I consider this as an entity? Yes. Can I consider this as an entity? Yes. So what we can consider as an entity? Entity can be anything. It can be any object, person, animal, anything it can be. And each entity will going to have its own attribute that represents the characteristic or a behavior of that entity. With the help of that attribute, we can represent the entity. For example, if I take this digital pen, so what it comprises of? It will going to have a height, it has a color, it has some weight, and it belongs to particular company. So all those are its attribute, right? Like with the help of that characteristic, we can easily understand this is an entity or an object. Then when we are representing this entity and how one entity is related to another entity with the help of diagram, then we can say that as a ERD or entity relationship diagram. So mainly it depicts the relationship between the data object and used in conducting the data modeling activity. So when we are going to use this ERD at the time of data modeling, already we know about the data modeling, right? When we are representing the simplified representation of a diagrammatic representation of software system and its data element. So here also it will going to mainly shows the relationship between the data objects, so which we are going to be used in the ERD. And also the attributes of each object in the entity relationship diagram can be described using a data object description. As I told, if I consider or if I wish to consider this as an entity, it also comprises of attribute, that is its characteristics or feature. Then we can able to represent these attributes of each object in the ER diagram, that too with the help of data object description. And also mainly it will going to provide the basis for activity related to data design. So how one entity is related to another entity, like what are the attribute it comprises of, whether it is simple attribute, complex attribute, whether it is multi-valued attribute. In order to represent all those attributes of a particular entity, then we have to use this entity relationship diagram. So next what we have, data flow diagram, or in short it is DFT. As the name indicate, data flow diagram, how data is flowing from one module to another module, like how it is flowing in a particular software or a system will be represented with the help of this diagram here. So that mainly it depicts the functions that transform data flow, and it also shows how data is transferred when moving from input to output. So in between what will going to happen, so we have to do the processing, like so if I wanted to convert any of the input to output, then processing has to be done. Then how data is moving from input state to output state, how processing is happening in between. So in order to represent that, we are going to have this data flow diagram. Mainly it will going to shows the transform data flow, and also it will shows that the data is transferred from moving, or when it is moving from input to output. So in between how transition is taking place from the input to output, that can be shown here. And also it provides the additional information which will be useful during the time of analysis of information domain, and also it will going to serve as a basis for the modeling of functions. So when we got to know how data is moving from input to output, how the processing is taking place, if we got to know regarding all those things, then it will be easy. And also we are going to use this data flow diagram in order to develop the models of the functional as well as information domain. So next what we have, process specification. So now we got to know that ERD, entity relationship diagram, and also we got to know regarding this data flow diagram. So now why we are going to have this process specification? This is also one of the element of the analysis modeling. So here why this process specification is important, what it will going to stores. So mainly it stores the description of each function present in the data flow diagram. So in the previous slide we got to know regarding DFT, that is data flow diagram. Then how one function is represent, like what are the functions we have and what each function is doing. So that is what description of each function will going to be represented in the DFT, that is data flow diagram. So in order to store all those description, we require this process specification. So in the process specification, it will going to have a complete description of the flow of a information or functions of that DFT which we have represented, and also it describes the input to a function, the algorithm that is applied for the transformation of input, and the output that is produced. So in the DFT we got to know that, right, from input to output we are having a conversion. So in order to do that, what is the input we are giving to a function and how it is processing, when it got processed, then what is the output that it will going to generate, all those will going to be described and it will going to be stored in the process specification. Then why we require this control specification? It will going to show the additional information about the control aspect of the software, whether we are using any of the utilities in order to control the software or in order to control the system. What are the additional features apart from the standard feature? That everything will going to be stored and described in this control specification. And also this control specification used to indicate how the software behaves when an event occurs. Certainly if any event occurs, like mouse over we have, if I click on the mouse, double click on the mouse, how software will going to behave when certain events are occur, and also which process are invoked due to the occurrence of the event, and also it specify once the event is occur, then what is the next step, what process will going to takes place. All those information will going to be stored in the control specification, and also mainly it will going to provide the details of processes which are executed to manage the events. Mainly it will going to shows that what is the software behavior when certain event is occurring, and what will going to be happen when certain event is occur, what is the further process is taking place, that is also going to be described in the control specification. Along with that, it provides the details of the processes which are executed in order to manage that event. So once the event is occur, that needs to be managed, then what are the processes we have in order to manage that event, even that is also going to be stored as a detailed document in the control specification. So next we'll see about the next diagram, state transition diagram. So now we got to know that, right, event, if something is in process, then we can say that as an event. So if event is occurring, then what will be the state, how it will going to be transmitted from one state to another state, then we are going to represent that in the terms of diagram, that we are specifying the behavior of a software when certain event is occur, how the state is transitioning. So that is what state transition diagram. So mainly it shows the various modes or behavior of the system, and also it will going to shows the transition from one state to another state in the system. So mainly this will going to specify the behavior or states of a system or a software when certain event is occurring, and also it will going to specify what is the transition of states we have when the certain event is occurring in the system. That will going to be specified with the help of this state transition diagram, and also it will provide the details of how a system behave due to the consequences of external event. If some external event is occurring, for example, when you plug in external software or any of the pen drive or any of the disk to the computer system, at the time it will going to generate one notification, right? That is what some state. So when certain event occurs, how state is, like how the representation of state is taking place, and how it will going to be transmitted, or how the transition is taking from one state to another state within the system will be considered and will be represented in the terms of diagram. That is what state transition diagram is here. And also it will mainly represents the behavior of a system by presenting its state and the events that cause the system to change the state. Mainly it will going to specify the states, and also it specify by which event the state has been changed from one state to another state. What made the system to change from one state to another state, that is also going to be represented. And also mainly it describes what actions are taken due to the occurrence of the particular event. If a particular event is occurring in the system or a software, then what must be the next process or a further process which has to takes place. All those changing of transition from one state to another state will be represented with the help of this state transition diagram. At last we have a data object description. Already we know about the object, real time element. When we are representing that, or with the help of this data object description, mainly it will going to help us in order to store and provide the complete knowledge about a data object which is present and which we are going to use in a software. Like what are the data object that we are using in a system or in a software. In order to develop a software, that data object description will going to store all the information or a complete information about those data object which we are using in a software. And also mainly it will going to give the details about the attributes of the data object which is present in the ER diagram. So already we know about the ERD, that is entity relationship diagram, how one object is related to another object, what are the attributes we have. All those data will going to be stored as a detailed element in the data object description, so that mainly it will going to incorporate all the data object and its attributes. What are the objects we have, what is its behavior or a characteristics in the terms of attribute. Everything will going to be stored and secured in the data object description. So at last we have data dictionary here. So mainly we have object, we have what entity, and each entity will going to have its own behavior and attributes will be there. Everything needs to be stored as a detailed information. So if I just look into that analysis model, then I must be able to understand, yes, this is what the system is all about and how it will going to be improved or developed. Everything we have to understand just by its document. So then in the data dictionary, mainly it will going to act as a repository. It will going to have a complete details of that consists of description of all the data objects that we are going to use or produced by the software. So whatever the data object that we are using and whatever the data object which will going to be produced after the software development, everything will going to be stored, and that collection is considered as what? Data dictionary. Mainly it will going to have a collection of data which is present in the software. As I told earlier, data will be considered as a resource, so that needs to be preserved in a well documented format. For that reason we have this data dictionary, and also this is crucial element of the analysis model. So we are going to consider this data dictionary as a crucial element of a software or a system or as of the analysis modeling. Why? Because if something goes wrong or if you are missing any of the data which is in the software development, even after the development of a software, if you have missed out any of the data object, then it will be it will going to lead to the failure of a software or a system. So that collection of all those data objects along with its representation of the attribute, that collection, huge collection or repository will going to help us, so that the maintenance of that data dictionary needs to be well mannered, so that the data dictionary will be considered as what? Crucial element of the analysis modeling. And also mainly it will going to act as a centralized repository. Why? Because data is a resource, that is an asset for the system development. So if something goes wrong with the data, we will be not able to develop a software or a system. So if analysis goes wrong, even development, design, everything will going to be wrong manner. So that in order to have this crucial part or crucial element of a analysis modeling, it will going to act as a centralized repository, and also mainly it will helps in modeling of a data objects which is defined during the software requirements. So when we are doing this or when we are having this software requirement, at that time we are also going to define the data object, so that all the data objects will going to be stored and collected in the data dictionary. So if we got to know, or if we just see the data dictionary, we will be able to understand what are the data objects that we have in the software. And even after the production or manufacturing of that software or a product, we will be able to understand what are the data objects that we had in the software or a system. So for that reason, this data dictionary will going to be very helpful in order to store or to retain the asset of the system software. It's all about today's session, as well as we are at the end of the unit as well. So in my coming session, we're going to see about the unit 3 of your software engineering. Until that, keep learning, keep on growing. Thank you.